Hello students, welcome to Vector Academy. We are starting our new series for the MCQ for science and our subject is physics today and we are discussing electricity chapter. We are discussing electricity MCQ chapters. So before we start, I'll give a brief introduction about this chapter. So let me add. So in electricity chapter, first of all, we talk about current. So current, what is current? Current is rate of flow of charge. Rate of flow of charge. What is the unit of current? Unit of current is charge unit is coulomb and time unit is second. So we can say that coulomb per second is the unit of current and it can be written as ampere. Now the second term is potential. Potential can be defined as, or we can say that potential difference. It can be defined as work done to move a unit charge through a cross section area of a conductor. So unit of the potential can be written as work unit is joule and the charge unit is coulomb. So it will be joule per coulomb. It can be written as volt. After that, in this chapter, we talk about Ohm's law. And Ohm's law is defined as if all the physical conditions like temperature, material and the room temperature all are constant, then we can say that our potential is directly proportional to current. Further, it can be written as V is equal to IR. If I draw a graph between V and I, so this will be a straight line for ohmic devices. All the ohmic devices will follow this graph. For non-ohmic devices, this graph will be non-linear. Will be non-linear. Now, the next part is here, this constant is known as resistance, which unit is O, and which symbolized by this particular symbol, omega. Now we will talk about resistance. So resistance can be written as potential upon current, and this particular resistance depends on various factors. The first factor is the length of the conductor. So resistance is directly proportional to the length of the conductor. Second thing, resistance is inversely proportional to cross-sectional area. Inversely proportional to cross-sectional area. And the third one, the temperature. And the fourth one is material. Material of the conductor. Material of the conductor. So these things on which resistance depends. And the next thing is when it is combinedly written as L by A, and if we remove the sign of proportional, there will be a constant which is known as rho, and also this rho is called resistivity. Resistivity. This particular constant is known as resistivity. This resistivity only depends on two factors. First is temperature and second is material. So if I say that I have a two wire, first is made up of copper and the second again it is made up of copper, then I'll say that resistivity of both the wires is same. Next, there are several combinations which you have already studied. First is series combination. Series combination of resistance in which resistance are at end to end points, in which your R equivalent was R1 plus R2 plus R3. Similarly, in parallel combination, of resistance, the resistance are added parallelly, like this, and your R equivalent for the parallel circuit R1 plus R2 plus R3. So this will be your R equivalent for the series combination, and this will be for the parallel combination. Next, we will talk about Joule's law of heating. Or we can say that Joule's law of heating, or we can say that heating effect of current. So if I have a R resistance and the current is flown through it, and if this resistance is very high, then this particular resistance will be show heating effect, and this heating effect and this heat produced is given by joules, which is I square R into T, which means H is directly proportional to I square. It is directly proportional to the resistance of the conductor and the time up to which the current is flown through the conductor. This is your Joule's law of heating. Next is power, or we can say that electric power. It is defined as electrical work upon time. Electrical work upon time. Since our work can be written as potential difference into charge, so if I put these values here, so here Q by T, which is known as current, so it can be written as VI. So here one formula of power is V upon I. Again, according to Ohm's law, V is equal to IR. So the next formula will be I square R. If I put the value of V here, again I can be written as V by R. So if I put the value of I here, so P can be written as V into V by R, which can be again written as V square by R. So these are the formula related to the power in various terms. Now, one more term, which is the electrical energy. Electrical energy, which can be written as power into time. Power into time. Here, the unit of power is joule per second, or we can say that watt. Joule per second or watt. Here, electrical energy, which is power into time, so its unit will become watt second. But the commercial unit, you already heard about it, which is kilowatt hour. Commercial unit, which is kilowatt hour, and this 1 kilowatt hour in joules, 3.6 into 10 to the power 6 joule, which is very important. Clear? So these are the some basics ideas of formulas related to the current chapter. So now we will discuss one by one MCQs, so we can apply our knowledge and concept in these questions. So first we will start through first question. So your first question is, you can see that in the circuit shown here, the ammeter A reads 5 ampere. Ammeter reads 5 ampere and the voltmeter V reads 20 volt. The correct value of resistance R, assume that the voltmeter is not ideal. Voltmeter is not ideal. You already heard about the voltmeter has infinite resistance. Infinite resistance, and voltmeter measure what it measures? Potential difference. Potential difference across resistance. So if this particular voltmeter is not ideal, so there will be a small current which is passing through this voltmeter, and overall current which is 5 ampere. So I can say that, let's suppose from resistor current I1 is flowing and from voltmeter current I2 is flowing. So we can say that I1 plus I2 is equal to 5. So here I1 can be written as 5 minus I2. 5 minus I2. Since this I2 is greater than 0, so this I1 will be less than 5. Less than 5. So further, I can write that since the potential drop across, it can be written as V by R should be less than I1. So here V, which is 20 volt, so 20 by R will be less than 5. So we can write further R will be greater than 20 by 5, which is equal to 4. So here is option. So R should be greater than, slightly greater than 4. So this will be our C option will be the correct answer. Clear? Next, the SI unit of energy. I already told about it. Energy is power into time. Power into time. So power unit is watt and second. This will be also the unit of electrical energy. And the one more unit you already heard about is joule. So joule will be the unit of energy. Next one, how much energy does a 100 watt electric bulb transfer in 1 minute? How much energy? We already talked about the formula power into time, and this power which is given 100 watt and the time which is in minute, so we have to convert into SI unit which is 60, so it will becomes 6000 joule. So our C option will be the correct answer for this particular question. Next, our question is following graph. You already looking at it. Following graph was plotted between the V and I across the metal wire, which the following statement are correct regarding this. So you can see that the graph between V and I for the ohmic devices is a straight line. So this is the graph for the ohmic devices which follow Ohm's law. So first option is the graph illustrate non-ohmic devices. So first option will be the wrong. While plotting this graph, the temperature remain constant. I already told about Ohm's law, that in Ohm's law, temperature and all the physical conditions remains constant. So B option will be the correct answer. We will also look at it. Third options and fourth option. So all of these will be not our answer because the first option is incorrect and the value of ratio V by I when the potential difference is 0.8 volt is not equal to the value of ratio. Since this graph is a straight line, so all the ratios for the V and I will be equal. So this option is also incorrect. Next, an electrical fuse works on. So electrical fuse, so fuse is a very high resistance and it has very low melting point. Low melting point. So when a huge amount of current is flow through the fuse, then due to high resistance, this particular resistance will give heating effect, and this particular wire start melting, and this particular connection will be the broken. So we can say that electrical fuse works on the heating effect of the current. So option C will be the correct answer. Next question is, if the current flowing through a fixed resistor is halved. If the current flowing through a fixed resistor which is halved, then the heat produced, we already discussed about heat, which is equal to I square RT, or we can say that heat is directly proportional to I square. So if current is half, so new current will be equal to I by 2. So new heat will be equal to, so we can say that since it is directly proportional, so H upon H dash will be equal to I square upon I by 2 whole square. So here I square by 4, I square and I square will be cancel out. So it will comes out 4. So heat H dash will be equal to 1/4. So here H is equal to 4H dash, or we can say that H dash is equal to H by 4. So our heat will be 1/4 if we halved our current flowing through the circuit. Next, which of the following does not represent electrical power? So we already discussed about the various formulas. First formula is I into V. We already written it. I square R. Then VI. Second formula is I square R, and the third formula is V square by R. So here, which formula is not correct? The C1. I square R is the correct, V square by R is correct, and VI is also correct. So which of the following does not represent electrical power? So which is I square R. Next question is, the resistance of the conductor is R. The resistance of the conductor is R if the length is doubled by stretching the wire. We already doubled, new length will be 2 times of R. Let's suppose initial length is L. Now the length is 2L. So if we stretch any wire, let's suppose its initial cross-sectional area A, and we stretch the wire remaining, or stretch our wire then the new resistance. So since our initial cross-sectional A, if we stretch a wire, the cross-sectional area will become A by 2 because our volume is constant. Because our volume is constant. So our cross-sectional area will become A by 2. So now new resistance. Let's suppose this resistance is R. So this resistance will be R dash. So we have to find out R dash can be written as, here R can be written as, since wire is same, so resistivity will be same, L by A, and this R dash will become L dash, resistivity same, and A dash, which is A by 2. So we can write that rho L dash is 2 times of L and A dash, which is A by 2, so 2 will be multiplied above. So here I can write 4 rho L by A, which represent our initial resistance. So R dash can be written as 4 times of R. Can be written as 4 times of R. So our B option will be the correct answer. Our B option will be the correct answer. The next question is, when a number of resistors are connected in series, when number of resistors are connected in series, so total resistance is equal to, so we already talked about, if resistance connected are in series, then their R equivalent will be equal to the individual sum of all these resistance. So inversely proportional to resistance? No. Sum of the individual resistance. Product of? No. Difference? No. So our B option will be the correct answer. Next, the device used for measuring potential difference. Device used to measure potential difference is known as. So if I talk about current, so current is measured by ammeter, and this ammeter has very low resistance. Very low resistance. And potential is measured by voltmeter, which has very high resistance. Very high resistance. So here we have to find out which particular instrument measure potential difference. So here our option is voltmeter. Galvanometer can also measure potential difference, but it should be a very high resistance in series with galvanometer. So here our answer is voltmeter. Next, which unit could be used to measure current? So what is the unit of current? Since we know that I is equal to charge upon time. So charge unit is coulomb and time unit is, SI unit is second. So coulomb per second, or it is combinedly written as ampere. So this unit will be the current unit. The next slide is, how much work is done in moving a charge of 3 coulomb across 2 points having a potential difference of 12 volt. So we already talked about the formula, which is potential difference is work done to move a unit charge through a 2 point along a conductor. So here we have to find out how much work is done. So our work can be written as potential into charge. So potential is given as which is 12 volt. So that would be 12 into charge, which is 3 coulomb. So work done will be 12 is a 36 joule. So our first option will be the correct answer. First option will be the correct answer. The next question is, unit of electric power may also be expressed as, unit of electrical power which is also be expressed as, we already talked about electrical power, which is E is equal to power into time. So power unit is watt and time unit is second. So watt second will be the correct answer, or it can be also written as joule. So our option correct, which is watt into second. Next, an electrical heater is rated 2 kilowatt, which is given power 2 kilowatt, and it can be also written as 2 into 10 to the power 3 watt. Electrical energy costs 4 rupees per kilowatt, and cost for the electrical energy, which is 4 rupees per kilowatt hour. So what is the cost of using heater for 3 hours? So if I use this heater 3 hours, what will be the cost of using it for 3 hours? So simple formula you have to learn, that is PhD, which is the particular electrical energy when we talk about in hours. So PhD, where P is in kilowatt hour, P is in kilowatt, H is hour, and D is days, and P is power, which is in kilowatt. If the P is not in the kilowatt hour, so you have to divide. If P is not in the kilowatt, so it is in watt, so PhD divided by 1000 when P is in watt. So here our P is given is kilowatt, so we can write 2 into R, which is 3, and D, which is 1. So our electrical energy will be 6 kilowatt hour. Since the cost of 1 kilowatt hour is 4 rupees, so our answer will be 6 into 4, which is total cost, which is 24 rupees. So our C option will be the correct answer. Clear? Next, which of the following represent voltage? So we have to find out which particular formula representing the voltage. So we already talked about voltage in terms of work is work upon charge. So first option is work done and charge. And charge can be written as, since your current is Q by T, so Q can be written as current into time. So that will become work done, and charge is current into time. So our first option will be the correct answer, which is representing the voltage. Next, the unit of resistivity. We already talked about that resistance is equal to rho L by A, where L is the length of the conductor and A is the cross-sectional area of the conductor. So here resistivity will be RA by L, and the unit of resistance we already talked about, this is ohm, and the cross-sectional area, which is in meter, so that will be meter square, and length is meter, so meter will be cancel out meter square, and we will left with ohm meter. So this is our unit of resistivity. I hope this is clear to you. Next, the maximum resistance which can be made using 4 resistance, each of resistance 1 ohm. So you have to remember one thing, that if you want to maximize your resistance, you have to add all the resistance in the series. If you have to minimize the resistance, you have to connect all the resistance in parallel. So we have to maximize the resistance. So we have to connect all these 4 resistance in the series. So that will become R equivalent, which is 1 by 2, 1 by 2, 1 by 2 and 1 by 2, which will be comes out 2 O. So our answer will be D. Next, if the area of cross section of a resistance wire is halved, if area of the cross section of wire, which means let's suppose initial is A and new will be A by 2, this is halved, so then its resistance become, so what will the resistance, new resistance of the wire should be? So let's suppose its initial length is L and length is constant, so we can say that since resistance is inversely proportional to the cross sectional area, so we can say that R upon R dash can be written as A dash upon A. So A dash is A by 2. Wait. That will be equal to R is inversely proportional to cross sectional area. So new resistance, since area is halved, so our new resistance will be equal to 2 times of A cross section, 2 times of R, 2 times of initial resistance, because they are inversely proportional. Clear? So that will become 2 times. Now next is, if the current through a flood lamp is 5 ampere, what charge passes in 10 seconds? So we have to calculate what charge will passes through this particular lamp. So current is given, so we know that I is equal to Q by T. So charge will be equal to I cross T, and I, which is 5 ampere, and time, which is 10 seconds. So our charge will be 50 coulomb. So our first option will be the correct answer. Clear? Next question is, a current of 200 milliampere flows through a 4 kilo ohm resistance. What is the potential difference across the resistance? So according to Ohm's law, we know that what we know, V is equal to IR. So we have to find out potential, and the current is 200 milliampere. So milli can be written as 200 into 10 to the power minus 3 into R, which is 4 kilo. 4 kilo can be written as 10 to the power 3. So here they will cancel out power because one is in minus and one is in positive. So total potential will become 4 to the 8, which is equal to 800 volt. That will be 800 volt. Next, 1 coulomb charge is equivalent to the charge obtained in electrons. So we have to calculate charge in electron, number of electrons. How many electrons will combinedly form 1 coulomb charge? So we know that 1 electron has a charge 1.6 into 10 to the power minus 19 coulomb, and total charge can be written as number of electron and charge on 1 electron. So here we have to find out 1 coulomb charge is equivalent to how many number of electrons. So our charge value is 1 coulomb and number of electron we have to find out, and charge on 1 electron is 1.6 into 10 to the power minus 19. So if we divide 1 upon 1.6 into 10 to the power minus 19, so it can be written as 6.25 into 10 to the power 18 electrons. So our second option will be the correct answer. Next, the work done in moving a unit charge across 2 points in an electrical circuit is measure of. The work done in moving a unit charge across 2 points in an electrical circuit is a measure of. This is the definition of potential difference. This is the definition of potential difference. That is the definition of potential difference, and we already talked about potential difference is work done per unit charge. Next, a current of 1 ampere, so current is given, is drawn by a filament of an electrical bulb. Number of electrons passing through across a section of a filament in 16 seconds. So we have to find out number of electrons which is passing through the 16 second would be roughly. So we know that current is charge per unit time. So here charge can be written as I into T, current which is 1 ampere and time is 16 seconds. So 16 coulomb charge will be passing through this particular filament. So we have to find out in roughly in number of electron. So since Q is equal to number of electron into charge on one electron, so our charge which is 16 coulomb can be written as N into 1.6 into 10 to the power minus 19, which is the charge on one particular electron. So N can be written as 16 upon 1.6 into 10 to the power minus 19. So it can be solved and can be approximately written as 10 to the power 20 electrons. So roughly it will equal to 10 to the power 20 electrons. I hope this is clear to you. The next slide is a piece of wire of resistance R is cut into 5 equal parts. So we have, let's suppose, L length conductor and this is cut into 5 equal parts. Since length is divided in 5 equal parts, so resistance since is directly proportional to length. So this particular length will be L by 5, L by 5, L by 5, L by 5 and L by 5. Since resistance is directly proportional to length, so each particular piece have resistance is R by 5. Now these parts then connected in parallel. They are connected in parallel, the equivalent resistance of the combination. So we have to find out the equivalent resistance of the combination. So we know that in parallel equivalent combination can be written as 1 upon R1 plus 1 upon R2 plus 1 upon R3, R4 and 1 upon R5. Since each piece has a resistance of R by 5, so I put all the values in this particular above equation. So R equivalent can be 1 upon R by 5, which can be written as 5 by R, 5 by R plus 5 by R plus 5 by R, 5 by R and 5 by R. So overall R, this particular sum becomes 25 by R, and this R equivalent is represented R dash in the equation. So our R dash will become R by 25. So we have to find out the ratio of R and R dash. So the ratio of R and R dash, so R upon R dash is equal to R by 25. So R and R will be cancelled out, so our result will be 25. So this is the combination in which we added all the pieces in parallel. So our answer comes out with 25. And this is the last question. A wire that has a resistance R is cut into two equal pieces. Again, if I have a L length conductor and it is cut into two equal pieces, so resistance will becomes half. So it has a resistance R by 2, it has a resistance R by 2. And these two parts are joined in parallel. Again, they are joined in parallel. What is the resistance of the combination? So we have to find out R equivalent. Since resistance in parallel combination is R equivalent is 1 upon R1 upon 1 upon R2, and it can be written as 1 upon R equivalent 2 by R plus 2 by R. So that will become 4 by R. So R equivalent can be written as reciprocal of R by 4. So I hope you like this section, and if you like this section, then give thumbs up and subscribe our channel, and we will come with the next particular topic, which is magnetic effect of electric current. I hope you like it. Thank you.